Hello everybody, welcome to my channel. Today we have a very good problem for you guys called rank transform of an array. Right? This is a very good problem, so make sure to pay close attention to the problem statement. Right? So it says given an array of integers, right? Replace each element with its rank. The rank represents how large the element is, right? So the rank has the following rules, right? So rank is integer starting from 1. The larger the element, right, the larger the rank. If two elements are equal, their rank must be the same. Rank should be as small as possible. This is a very good problem statement, very nice and concise. So essentially what they're saying, right, we'll be giving an array of numbers, and we need to return an array that represents the rank relative to the other elements in the array, right? So for example, the smallest element will have a rank of 1, and the largest element in the array will have the largest rank, right? So for example, we got 40, 10, 20, 30, right? So 10 is the smallest one, right? Which is has an element of a rank of 1, right? Because that's the smallest one. And then the second smallest one is 20, right? So it has a rank of 2. The third smallest one is this one, right? We could have it has a rank of 3, and then the largest one, right, which is 40, has a rank of 4. This is how we're able to get that, right? And this one's, you see that we have 100, they're all the same element, right? So if they're the same, right, they should all have the same rank. If two elements are equal, their rank should be the same. And that's what we end up with the 1, 1, 1 here, right? That's kind of the whole point of this, right? Same elements share the same rank. So they all contain 1, right? Because they're all the largest and smallest ones, right? And this example is just a longer example of that, right? But it's the same principle, right? We need to rank, return the rank of each element, right? That's what we need to do, right? So it starts from 1 and then work its way up to the largest one, right? Yeah, so how do we go ahead and solve this, guys, right? How do we go ahead and solve this, guys, right? So naturally, my intuition for this problem, right? The solution I came up with was the heap approach, right? Because, if you got to think about it, right? Each time we need to find the smallest number, right? Let's say we want to start, creating our output result, right? We would get the smallest element. And then say I code that element has a rank of 1, and we get the second element, right? So it naturally translates well into using a heap data structure, right? We use heap to solve many different kinds of problems on this channel, especially those k problems. We need to find the k largest, k smallest, right? For this particular problem, main heap would be just fine. We just take elements one at a time and give them their rank, right? So we would also need, right? So we would add these distinct values, right? So also, so let's say we take 10 out of the heap, right? Because that's the smallest one, right? So after adding all the elements to the heap, we take 10 out because that's the top of the heap, right? And then we will also, when we need to keep track of the index, right? That, or the index is that, so this one, there's no duplicate, right? So it's straightforward. So we will look, save that information somewhere, right? So we say 10, which index where you're at, and then we just put it, you have a rank of 1, right? And then we go on to the second smallest one, right? Because the heap will have at the top, the smallest element, right? So that's what we use a mini heap, right? So we get that as the second one, we put it there, right? Pretty easy, pretty simple, right? So we know that we need to do something like that, right? And also we need to keep track, right, of the indexes. Also, we need to keep track of the indexes, the original indexes that the original elements were at, right? Because since when we're creating it, we can keep we can put the insert at the right, because 40 is at the first index, right? So we need to give it a rank of 4 because that's the largest one, right? So the index is going to play a role, right? So we need to keep track of that as well, right? So that we can output it, we could put the right data at that particular index, right? So so another approach that we could do that I think about, right, it would be to which is the approach that we're going to end up going with, right? We're going to be adding so we would pretty much sort it, right? So what we would do, right, we would sort it. So we start off with 40, right? So say we got the original array. All right, go ahead and sort it, right? So 10, 20, 30, 40, right? Sorting, right? And then let me zoom in a little bit, all right? Okay, zoom in more. I think this one's better. And then, all right, after sorting, right, you create our output results, right? So now we run into some sort of trouble, right? We will return also, what would it be? Would it be 1, 2, 3, 4, which is incorrect, right? This is not a valid response, right? We need to keep track of the ordering of the original right? The original array, right? Right? So you just need to, uh, you know, uh, put the data. So we need to return it in that particular order, right? Of where the elements are at, right? So it makes it a little bit more challenging, right? Because we need to keep the original order that it was before as well, right? So how do we go ahead and do that, right? So we know that we would need to do some sort of sorting, right? The sorting is gonna be important so that we could easily just give rank to different numbers, right, as we go along through the array. So what I'm thinking, when you do, we need to store some sort of additional information, right? So how about for each number, for each index, right, I add another piece of data to it, right? So 40 would be considered to be index 0, right? So we'll be storing the number in its original index, right? Okay. So after storing that with the original index, we would do 10, 1, right? And the next one would be 22, right? And then the last one will be the 30 index 3, right? So I have the index for each of the numbers, right? The original index, right? So you're gonna see where you guys will see how it's gonna be useful, right? So after storing the index, what we can do now, we can go ahead and sort them, right, based on their actual value, right? So now we would have this, right, after sorting it based on the value, right? So we got 10, right? Then we got 20, right? The next to be there, we got 30 as well. Okay. And what else? We have 40, right? So we got 40. So everything is sorted based on their value, right? So now that we have the sorted array, right, based on the value. So now we are in good shape to just go ahead and populate our output result, right, which can easily be done doing this, right? So originally the array is the output result is going to be the size of the array, right, filled with zeros, right? And then we would go ahead and go linear loop through the array, right? So we check 10, right? 10, your index 1 has a rank of 1, right? Because that's the first element in the array, right? After sorting the elements, right? So it means that that's the smallest number, right, in the array. So it has a rank of 1, right? And the second smallest, right? We go into 20, right? We say, what's your index? Index 2. Okay, let me put a rank of 2 there, right? Because each time we're also incrementing the rank variable, right? Okay. So right now it's 2, right? Because we have 10, 20 is not the same number as 10, right? So they're not the same value. So he's gonna have a different rank, right? So he has the second largest rank that you could have, right? And then we go to 30, do the same thing. We know the exact index it's at, right? We know it's at we know it's at index 3. Yeah. We know it's at index 3. So we go ahead and put the next largest rank you could get, right? Because it's not the same as this one, right? So then we go to 40, which is at index 0, right? So we just put the next largest rank, because it's not the same as the previous element, right? So we put 4, right? Just like that, we have the answer at just like this, right? So this one will work out the same way if we do it real quick. So everything will have a rank. So for the first one, it's gonna have, we store the original indexes, right? So it'll be the same for each of them. Right? So this is for index 1, this is for index 2, right? So after doing that, we sort them, right? And it's the same thing, right? Because it doesn't change. So now we create our output results. So how it would work? We would put so the first one rank is so the rank would equal to 1, right? Because that's the smallest rank you could start with. So we get 1, and then we check 100, right? That's the first smallest element, right? To the index 0. So we put 1 there, right? And then and then we check, right? Once we get to this index, we check, is this number the same as the previous number, right? If it is, then we keep the same rank, right? We don't increase it, right? And then we do the same thing for here. And that's how we can end up every time with this, right? So the code would make a lot more sense once you go through it, right? It's gonna be very intuitive. So let's quickly go ahead and code that up. Now the code is gonna be very intuitive. So what we're gonna do, we're gonna have our paired structure, right? Because I told you guys we want to capture the index, okay, as well, right? So paired structure is going to help us to contain that, and then what we're going to do, we're going to loop through the array real quick. I equal to 0, I is less than I of that length, I plus b. Okay. So what we're going to do is do pairs I go to view x of the array, the value that it was, right? That it is, and then in its index, right? So we store that information. We get that what we want. And then what we're going to do next is to simply go ahead and sort it, right? Let's sort our array. We're going to pass in our pair array, right? And then we're going to take in A and B. So we're going to be doing it based on the value, right? Because we're storing the actual values of the elements, right? So store it based on that. So that the smallest element is at the beginning, right? Okay. Okay, now we got that part sorted out. We're pretty much clear to go now. We got our thing in sorted order the way we want it. All right, so now it's time for us to start building our output result, guys, right? Okay, so it's going to be already that length, right? So initially it's going to be a bunch of zeros. Okay, so now we're going to need our rank variable. It's going to equal to 1, right? Because that's the smallest one you can get. And then we're going to go ahead and start it off. Doing a linear loop going in there. So I is equal to 0, I is less than paired element, I plus plus, right? So now what we're going to do res of, right? Of so now that they're sorted, right? We have it in this particular order, right? You know, so now we need to capture, right? So where's the original index of this element, right? So I could put its rank, right? This value, right? So we get that because we're smart, we're able to store it in that in the paired, right? You know, as a second index. So it's going to be pair of I of 1, right? Is equal to paired in the actual value, not of I put a rank. I meant to say right there, rank. Okay. So now we need to handle the case where we have like those the same. We need to know when to increment it or not, right? You know, if we have a bunch of the same elements, right? We want to keep using the same rank, right? Because they're the same, right? Okay. Okay. So what I'm gonna do here is to just check, right? Okay, is to check if I is greater than 0, and right the so period of I, right, of 0 is not equal to the previous or I 0, but I minus 1, right? You know, so if they're not the same value, so after we get this one, right, this one that we did here, we put 1 there, and then we go ahead and check, right? Is it the same as this one, right? If it's not the same, that's when I'm going to increment it, right? So if it's not the same, then I can safely increment, right? Because we want the other rank, right? For example, we do here, right? We sorted, we got 10, right? We put 1 because it's the smallest element, and then we see there, we check, is this the same as this one? Right? That's the check that I'm doing there, right? If it's not, then we're good. We increment it plus 1 so you could get the second largest rank, right? Okay, so hopefully it makes sense to you guys. So yeah, after that we turn the results, right? So I think we got everything. Let's try to run the small test cases. So it looks like we've got the small test cases. Let's press submit. Awesome, guys. We would have passed all the test cases, guys. If you guys found value in the thought process, let me know that in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching. and I'll see you guys in the next video.